Good day, grade 8. How are you guys doing? Welcome to this physical science lesson. This is lesson number 10. We are looking at the topic friction. Okay, we're looking at the topic friction. In the previous lesson, we just finished off on the concept of energy, where we looked at different forms of energy. And I think it's important that you guys go on to look at the renewable, the non-renewable energy. Try to look at the types of energy sources that people are now using, which are clean forms of energy. And clean forms of energy is energy that doesn't pollute. That's basically the main concept with it. Okay, but now we want to move on to the topic on friction. It's a completely different area in a way, but these are the objectives for today's lesson. Okay, by the end of this lesson, you should be able to define the term friction. You should be able to describe situations in which friction is useful, describe situation in which friction is problematic. We are also going to look at how friction affects moving bodies in different environments, to say when on land, when in the air, and when in the water. Okay, so it's important that you get to understand that there is friction that is acting on bodies in all the different mediums that we have, as in air, water, and the ground. Okay, so those are our objectives. Just look through them. Try to recall in your mind what you think friction is. Okay, so we will find that the definition of the term friction is very simple. This is a force that opposes motion, right? This is a force that opposes motion. So if you are walking, you're trying to, or you're running, or you are sliding, and you think you are a superhero and you're sliding, and then you think you're going to slide from here, I don't know, to Oshakati or to wherever. You can't do that because there is grip. Right, there is a rough surface on which you're walking on or on which you're trying to slide on, and sooner or later you're going to stop. So friction acts in the opposite direction to the motion of an object. So if you're moving forward, friction is actually going in the opposite direction to where you are going. That is what friction is. And I gave an example here to say, if there was no friction, the body would continue moving forever. And then if you were in the dining hall, just imagine you are there by, I put an example where you are by the saving point, and maybe Metulik is about to give you food, right? And then you get a big piece of meat, or I don't know, whatever happens, that then you go whoop, and then you want to slide, right? You slide. You guys always like sliding and stuff. Then if you slide and the surface of the dining hall, the floor, the tiles in the dining hall, if they are completely 100% smooth and there is no friction, you're going to slide and you're not going to stop. You're going to slide until you go and you bump into the wall. That's how far you will slide. And it's only the wall that will stop you. That's if there is no friction. If there is no friction and there is no body stopping you from moving, you will slide forever, right? But here on earth, there is friction on the ground, there is friction in the air. When it's in the air, we call it air resistance. When it's in the air, we call it air resistance. So now, let's look at different objects. Let's say if you look at this ball, right? If this ball is moving, if you kick it, right, it's going to move in a certain direction. But as it moves, it will slow down because of friction. Let's look here. We have, I don't know if you guys know anything, something called, these are ice skates and these are roller skates. You guys are cool guys, so I'm sure you know. These are ice skates and these are roller skates. When you're wearing ice skates, we don't have any ice rigs here in Namibia because we don't have snow. It doesn't snow here in Southern Africa. But if you're in a place where it snows and there are ice rigs, then if you are skating, you find that the people that skate, right? If you are moving where there is ice, the amount of friction is much, much less, right? Because ice is very smooth and therefore very slippery because the edge or the surface is not rough. The edge or the surface is not rough. The same thing with roller skates. But now when you're wearing ice skates, observe that when you're wearing, if you were to walk on an ice rink, right, if the whole floor was just frozen solid and it's ice, if you wanted to walk with it with your feet, you would slide and you would actually do splits and probably break your legs. But these ice skates actually increase, right, actually allow for you to have some grip on the ice and for you to be able to ice skate. Okay? Same with the roller skates. The roller skates, they also have a bit of grip on the ground. They reduce, though, the friction, which is why you're able to roll for a big distance. What about this situation where we have this individual, this hand? It's just a hand. It's a hand. It doesn't even have an owner. The hand is holding a bottle of water. Whenever you're holding something, right, whenever you're holding something, you can only hold it because there is friction between your hand and the bottle. That's the only reason why you're able to hold it. If there was no friction, the bottle would just keep on falling out of your hand. The bottle will keep on falling out of your hand. We have a situation here, if you've gone to the mall before, you have seen times when maybe someone is cleaning a place, any place in the mall, and they put this caution sign and they say wet flow, to say please don't pass by here. It's for your own good. Then you're thinking, oh, why is this guy putting this sign? Why doesn't he want me to pass through here? It's easier for me to pass through here. If you walk through where it's wet, it's most likely that you're going to slip, you're going to fall, and you're going to bump your head, and you're going to have this big bowl, this big bump which you get when you fall onto the ground, right? So those are situations where we can actually get to see friction in action. So I also put in here situations where we say friction is important, right? When is friction important? Friction is not all bad. There are times when friction is important. An example that I gave here was with brakes of cars and the bicycles. If you're cycling and you're riding your bicycle, you need to have brakes. Otherwise, that bike is going to be rolling down a hill. You're going to be moving so fast, you can't stop, right? And you're going to end up crashing. If your car is moving too fast, you need to put on the brakes and slow it down, as with any other moving vehicle. So when we look at the sole of our shoes, the example that I gave here, you are able to read. You guys are able to read, so I won't read everything. You guys are able to read. But just understand that we have situations where friction is important and situations where friction is not important, where friction is actually a problem, a nuisance, right? We have situations where you have friction leads to the wear and tear of machines because machines have different parts that are always rubbing against each other. And as they rub against each other, these parts end up breaking down, right? Because they are being worn out. So if you have a lot of friction, you'll find that if it's a vehicle, if it's your bicycle, or if it's any other tool or apparatus that you're using, if there is too much friction, then it's going to lead to the apparatus breaking down. It's going to lead to the apparatus or the machine breaking down. So we have ways of now reducing friction. We can reduce friction in situations where we don't want the friction. If we think that, okay, friction is bad, is going to damage my machine, what I want you guys just to do now, you can, at any point during this video, you can pause the video and go back over some material that you think you don't understand. Okay? So sometimes I won't pause the video or I won't give the instruction to say pause the video, but always have it in your mind that you can always pause the video, go back, look at how we reduce friction or how friction is important, or if you want to see something, whatever it is you want to see. Don't always wait for my instruction. So sometimes we want to reduce friction. And how do we reduce friction? How do you think we can reduce friction? I've put some ways that we will reduce friction here. If you have different ways that you think of, you can also tell me in the lesson. Just say, sir, that time you wrote lubrication, ball bearings, but I think we can also reduce friction in this way and in this way. I am open, I am welcome to your ideas, right? Then I also put a part on the effect of friction in movement in air and in liquids. To say, when you have a body that is moving in the air like an aeroplane, okay, you think that since it's moving in the air and we don't see anything, but there are a lot of particles. Remember, air is actually composed of gaseous particles, right? And those gaseous particles, actually, that's matter also that's in there, right? And this matter is actually going to resist the movement, is going to resist the movement of an object. It's going to resist. So there is something that we call air resistance. So if you are moving, if you've ever been at the back of a bakkie, right, and then you're at the back and the car is moving and then you feel the air, you say, I want to feel the air blowing on my face or blowing through my hair, right? That the only reason why you can feel the air blowing through your hair or on your face or pushing you backwards is because there are particles that are in the air, and that's what we call air resistance. You are trying to move forward, but it's trying to pull you backwards. That's what we call air resistance. So you'll find that jets and aeroplanes are designed in a way so that the air just flows. They're almost streamlined. Like I put the word streamline on bodies in water as in fish. But it's also there on jets, right? And on vehicles also. Most of our modern machinery is built and designed in such a way. If you look at F1 cars, or if you look at SUVs, sports utility vehicles, right? Those ones which move very fast. They have these smooth surfaces, and the design is actually designed like that to allow it to have least air resistance, which makes the car move faster, or the aeroplane move faster, or the jet move faster. Same concept, same principle for fish in the water, submarines in the water, right? So that's friction, guys. That is that on friction. I will talk to you guys in just a minute or so, because if you're reading this, that means, or you're watching this, or you're listening to this, that means you are in the lesson. So thank you very much, guys, for watching the video. Goodbye.